So, uh, imagine walking into the boardroom of a Fortune 500 company, right?
Hmm.
And you just slam down this 400-page SAP financial log on the table.
Oh, wow. Yeah, that sounds like a nightmare already.
Right. It's just filled with raw, unformatted transactional data. And then you turn to an intern and tell them, hey, give me a strategic breakdown of our supply chain vulnerabilities by lunch.
I mean, that intern they're not just going to fail, they're probably going to quit on the spot.
Exactly. They would walk right out the door. But today, we are actually looking at a set of architectural blueprints that takes that exact highly complex scenario and, solves it in milliseconds.
It really is incredible to see it mapped out.
It is. So, welcome to the deep dive, everyone. We are extracting the ultimate roadmap from this stack of dense, highly technical architectural diagrams and diagnostic matrices that you all provided.
Yeah, the mission today is really to take you on a journey from what they call code to value.
Right. We're examining how to architect these generative AI workflows by basically marrying three huge platforms, SAP, AWS, and Amazon Bedrock.
Which is quite the trio, honestly.
It really is. And right off the bat, I think we need to draw a hard line here, like a line between the AI that you probably use every day and the enterprise AI we are discussing today.
Yeah, that distinction is it's super important to make early on.
Because consumer AI, the chatbot on your phone or that web interface you use to draft an email that's a discrete tool, it's kind of like that clever intern we mentioned.
Right. You give it a standalone task, and it just returns a standalone result.
Exactly. But the architecture we are dissecting today is fundamentally different. By combining SAP's data foundation, AWS's elastic compute power, and Amazon Bedrock's reasoning models, we aren't just building a chatbot.
No, not at all.
We are building this centralized, highly secure, unified digital brain for an entire massive corporation.
And, the distinction in scale and consequence there is just profound. I mean, we are no longer operating in a vacuum where an LLM is just generating plausible-sounding text based on its pre-training data.
Right, the stakes are way higher.
Way higher. We're looking at foundational diagrams that show how massive global organizations are wiring their most critical proprietary data, literally the actual lifeblood of their operations, directly into the cognitive reasoning centers of cutting-edge models like Claude 3.
It's wild to even think about.
It is. And they're doing this through a very specific, tightly coupled triad of technologies.
That SAP, AWS, and Amazon Bedrock triad. And just to give you the roadmap for this deep dive, we're going to trace how organizations actually implement this stuff in the real world.
Right, because it's not just a switch you flip.
Exactly.
Yeah.
We are going to move through three evolutionary stages that are outlined in these blueprints. So that's augmentation, interactivity, and productization.
But before we get into the granular execution of like a serverless pipeline or the mechanics of a prompt factory.
Which we will absolutely get to because it's fascinating.
Oh, for sure. But first, we have to establish the playing field. We really need to look at the destination, which the sources refer to as the master blueprint.
Okay, let's unpack this master blueprint because it looks intense.
It is, but it's fascinating because it completely dispels the myth that AI is just this plug-and-play appliance. When you synthesize these diagrams, it becomes glaringly obvious that true enterprise GenAI is a complex ecosystem.
Right. It's not just one software tool.
Exactly. It requires three distinct, non-negotiable pillars to actually function at scale.
Okay, let's dig into those pillars. I've spent a lot of time looking at these diagrams, and I want to break down why each one is critical. Let's start with the bottom layer.
The foundation.
Right. The blueprints identify the first pillar as the data foundation. And in this specific architecture, we are looking at SAP S/4HANA, particularly SAP S/4HANA Cloud.
Which is a beast of a system.
Oh, yeah. For any enterprise listening, SAP is the ground truth. It is not like an approximation. It is the highly structured, deterministic ledger where the reality of the business actually lives.
Yeah. We're talking about supply chain telemetry, financial general ledgers, real-time inventory counts, HR records, all of it.
So my read on this is that without this robust foundation, the AI is effectively an amnesiac. Like, it might have great reasoning skills, but it has no memory and no contextual awareness of the company it actually works for.
That is a highly accurate assessment. The data foundation is literally the corporate memory. And what makes SAP S/4HANA critical here is its in-memory architecture.
Right, the speed factor.
Exactly. We aren't talking about querying some stale data warehouse extracts from, last week. We are talking about tapping into a live, high-speed transactional nervous system.
But as you noted, raw data alone isn't intelligent.
No, it's just numbers sitting there.
Right, so it requires the second pillar to extract meaning. And the blueprint labels this the cognitive engine. This is Amazon Bedrock.
Yeah, and the blueprints specifically highlight using foundation models like Anthropic's Claude within Bedrock.
So if SAP is the memory and the hard facts, Amazon Bedrock is the reasoning center. It's the engine providing the synthesis, right?
Exactly. It's understanding the semantic intent behind a human query and then generating the natural language response.
To put it in perspective for you, all SAP knows that, say, warehouse B contains exactly 10,432 widgets.
Right, a hard fact.
But Bedrock is the component that can read a supply chain manager's panicked question like, are we going to stock out of widgets before the Q3 promotion? And it can actually reason about what that entails.
It connects the dots.
Yeah.
And that separation of concerns is vital for enterprise security and scalability, you know.
How so?
Well, you aren't training an LLM on your SAP data. That would be a complete compliance nightmare.
Oh, right. You don't want your proprietary ledgers baked into the model's weights.
Exactly. You're keeping the data securely in SAP and just using Bedrock's models strictly for their reasoning capabilities at runtime. But here's the catch. Those two massive systems, SAP and Bedrock, they do not speak the same native language.
They don't just inherently know how to talk to each other.
Right. They need a translator.
Which forces the need for the third pillar, right? The orchestration layer. In this blueprint, that orchestration is handled by AWS infrastructure, specifically AWS Lambda for compute, API gateway for access, and frameworks like LangChain or Pandas AI for the logic.
Yeah, the orchestration layer is essentially the connective tissue of the whole operation.
It intercepts the human intent, figures out what data is needed, generates the SQL or Python to query SAP, passes that raw data back up to Bedrock for synthesis, and then delivers the final answer.
It's managing all the dependencies in the routing. It acts as the intelligent governor for the whole system.
Okay, so we have the data foundation, the cognitive engine, and the orchestration layer.
Yep. Those are your three pillars.
But you know, what I find most compelling about these sources isn't just this destination, it's the journey to get there. The architecture introduces this concept of a GenAI maturity continuum.
The continuum. Yeah, this is crucial.
It maps organizations moving sequentially through level 1 to level 2 and finally to level 3.
Right. It's a step-by-step evolution.
But I kind of have to push back on that framework a bit. Like, why is it presented as a mandatory continuum?
What do you mean?
Well, if I'm a CIO and I have the budget, right? I can buy the SAP HANA licenses today. I can spin up the AWS infrastructure this afternoon, and I can invoke Claude 3 via Bedrock by dinner.
Technically, yes, you could.
So why can't a company just look at this master blueprint and jump straight to level 3? Why not build the massive, fully integrated serverless AI application on day 1?
Well, if we connect this to the bigger picture of, enterprise change management and risk tolerance, jumping straight to the end is pretty much a recipe for a catastrophic, highly publicized failure.
Really? Just because of the complexity?
Not just the technical complexity.
Yeah.
The continuum levels 1 through 3 isn't merely a deployment schedule. It represents this mandatory evolution of organizational trust, infrastructure hardening, and complexity management.
Ah, I see. You mean proving to the security and compliance teams that the AI isn't going to, accidentally email the Q4 earnings report to the entire company?
That is a very, very real concern. Consider the perspective of a chief risk officer, right? If you declare on day 1 that an autonomous AI agent is going to have direct serverless access to the deepest financial ledgers in SAP, and it's going to dynamically generate SQL to answer any query from any employee.
Yeah, that project will be shut down before it even starts.
Exactly. The risks of hallucinations, data leakage, and unauthorized access are just astronomical at that stage. So the continuum is designed to mitigate that exact panic.
It forces a company to prove value and secure the architecture incrementally.
Right. You move from having the AI read static documents in isolation to allowing constrained, frictionless interaction, and only then do you graduate to scalable, serverless applications.
That makes a lot of sense. You have to prove the AI can read safely before you let it talk, and you have to prove it can talk accurately before you let it run the entire building.
That's a great way to put it.
Okay, that logic tracks. So let's start at the very beginning of that continuum, level 1. The sources label this augmentation.
The entry point.
Right. And looking at the diagnostic matrices, this level seems purpose-built to solve a very specific, deeply ingrained pain point in corporate operations. Basically, the manual data slog.
Oh, the manual slog is just the silent killer of enterprise productivity.
It really is.
We are talking about highly specialized professionals spending hours, sometimes days, parsing through static, document-heavy workflows just to extract baseline operational metrics.
And the blueprints provide a highly relatable anchor for this problem. They point to a classic static, high-density SAP report, specifically a file named rfssld000.pdf.
The dreaded PDF.
Exactly. Now, if you've ever worked in enterprise finance or supply chain or operations, you have encountered a document exactly like this.
Oh, absolutely.
It is this massive, impenetrable PDF. It is essentially a raw transactional log dumped into a fixed layout document, packed line after line with ledger balances, obscure operational codes, and just unformatted tables.
It is a pure artifact of legacy reporting. Historically, extracting actionable business intelligence from something like that, from RFS SLD00.pdf, requires an enormous amount of human capital.
Right, because you can't just Ctrl-F your way to a strategic insight.
Exactly. A highly trained financial analyst has to manually read through the static logs, cross-reference account numbers, parse the raw balances, and then manually type up an executive summary.
And by the time that summary is finished,
The data is already stale. It's practically useless for real-time decision.
which introduces Blueprint 1, the prompt engineering factory. This is the architectural solution for level 1 augmentation.
And it's important to note, at this stage, we aren't building a conversational agent yet.
Right, we're building a highly deterministic extraction machine.
Yes. According to the blueprint, the primary AWS service utilized here is Amazon SageMaker, specifically operating within SageMaker notebooks.
Okay, so how does it work?
The architecture takes the raw text extracted from that dense PDF and passes it via the Bodo 3 Bedrock client directly to the Claude 3 Sonnet model.
Okay, I want to spend some time on the actual mechanics of the prompt engineering here, because the sources detail a very rigid three-part structure for this.
It's restructured, yeah.
And I think it really demystifies what prompt engineering actually looks like when you move past, consumer-grade tinkering and get into real enterprise execution.
That's a great point. The precision of the prompt at this level is literally the difference between a reliable data pipeline and a useless hallucination engine.
So as you noted, the blueprint breaks this down into three distinct components. What's the first one?
The first is the system prompt. This is where the developer defines the operational persona and sets the rigid boundaries for the foundation model.
Okay.
In the architecture, the system prompt is explicitly defined as, you are a great finance analyst, which can analyze the health of a company based on a financial report.
Right, so it's essentially establishing the neural weighting for the entire interaction. By declaring it a finance analyst, you are forcing the model to access the latent spaces of its training data that deal with GAAP accounting, financial ratios, and like a professional corporate tone,
Yep.
while simultaneously downweighting unrelated, creative, or conversational concepts.
Precisely. It sets the analytical rigor. You don't want it acting like a poet. You want an analyst.
Makes sense. What's next?
The second component is the context. Because, the AI cannot analyze what it cannot see.
Right.
The blueprint illustrates this with a standard Python execution.
Yeah.
It's pypdf.pdf reader, or SSLD00.pdf.
Yes, is extracting every single UTF-8 character and injecting that massive wall of text directly into the AI's context window.
And because Claude 3 Sonnet has such a massive context window, it can ingest that entire dense report in one shot. You don't need complex chunking or a vector database retrieval at this stage.
Exactly. It just swallows the whole document. Okay, so we have the persona, we have the raw injected context. That brings us to the third component, the user prompt.
The execution command.
Right. The blueprint defines it as analyze the result of the report below and provide an executive summary with insights.
So the whole architecture basically mimics hiring a brilliant financial analyst, locking them in a clean room, handing them a single dense file, and giving them a hyper-specific output directive.
Which is kind of funny to visualize, but because this entire process is heavily constrained within a SageMaker notebook environment, it satisfies all those security requirements of level 1.
Yes, the data isn't exposed to the public internet, and the interaction is easily auditable. It's very safe.
But looking closely at the code snippet in Blueprint 1, there is a hyper-specific parameter that really caught my eye.
Oh, which one?
When the script invokes the Bedrock model using that Bodo 3 Bedrock.invoke model command, it specifies the Claude 3 Sonnet model, but it also hardcodes a parameter. It sets temp 0. The temperature is set to absolute 0.
Yes, the temperature setting.
I want to dive into this. Because in the broader conversation about generative AI, we are constantly told that we want the models to be creative, right? Fluid, capable of lateral thinking.
That's the usual selling point, yeah.
So why would an enterprise architect deliberately lobotomize the creativity of the model by setting the temperature to 0?
Well, what's fascinating here is that in the context of enterprise data extraction, creativity is not just unnecessary. It is an existential threat to the pipeline.
An existential threat.
Absolutely. Temperature is the hyperparameter that controls the probability distribution of the next token generated by the model.
Right.
A high temperature flattens that distribution, meaning the AI might intentionally choose less probable, more varied words,
Yeah.
just to sound more conversational or poetic.
Which is fantastic if you were asking the LLM to write, like, marketing copy for a new product launch. You want that variance. You want it to brainstorm.
Sure. But if you are extracting cost of goods sold from an SAP financial report,
Yeah,
variance is catastrophic.
I can see that.
If the actual number in the PDF is $1.69 million, you do not want the AI deciding that $1.7 million sounds more poetic.
Or rounding it because it feels like it.
Exactly. Setting the temperature to 0 forces the Claude model to become purely deterministic. It will always select the single highest probability token based strictly on the injected context.
So it mathematically neutralizes the risk of hallucinations when parsing hard numerical data.
You've got it. You're intentionally turning a generative engine into a deterministic calculator.
Wow. And looking at the business impact of this level 1 architecture, the results are undeniable. The blueprint shows the raw, unstructured PDF text being instantly converted into a highly structured JSON executive dashboard.
That JSON conversion is huge.
It is. And I want to emphasize the granularity of what this architecture pulls out of the mud here. It doesn't just give a vague summary. The JSON output extracts exact integer values.
It's extremely precise.
It lists $4,223,226 in domestic revenue.
Yeah.
It successfully isolates $526 in affiliate revenue. It dissects the cost of goods sold into highly specific operational buckets.
Like what?
Well, it shows direct materials at $1.69 million, personnel time at $195,000, and machine time at $140,000. It even flags massive inventory balances, isolating $42.9 million in raw materials versus $6.9 million in trading goods.
And that shift from unstructured text to a structured JSON format, that is the real architectural victory here.
Because JSON is machine readable, right?
Exactly. This means the output isn't just a block of text that a human still has to read. It is a structured data set that can be programmatically routed to a downstream database.
Or used to automatically populate an executive dashboard without any human intervention at all.
Precisely. And the blueprint also shows that alongside those structured key value pairs, the zero temperature prompt still manages to generate a coherent executive summary paragraph.
Yeah, I saw that. It synthesizes the data, noting that the report provides a comprehensive view of the financial position. It specifically calls out the significant inventory balances and substantial cash holdings.
And it does all that analytical heavy lifting in milliseconds.
This completely redefines the reporting cadence for an executive team. You no longer have to wait until Monday morning for the end-of-week ledger summary.
Nope. The SageMaker instance can process the PDF the exact second it is generated by SAP.
It is a massive optimization of human capital. The analyst is finally freed from that manual extraction process and can focus purely on strategic action.
It's a huge win. However, and this is a big fear, however, level 1 is fundamentally static.
Right.
It is a batch processing one-way street.
Yeah.
The architecture ingests the document, generates the JSON summary, and then it terminates.
Right. And a static JSON response is ultimately a dead end the moment human curiosity gets involved.
Oh, absolutely.
Because if I am the CFO reading that generated summary and I see $42.9 million tied up in raw materials, my immediate reflexive action is going to be a follow-up question.
Of course it is.
I am going to want to know, why is our raw inventory variance so high compared to last quarter? Which specific warehouse is holding that material?
And you can't ask a JSON file that.
Exactly. You can't interrogate a JSON file. The architecture hits a hard wall. And this inherent limitation in level 1 is what forces the enterprise to evolve to level 2 on the maturity continuum.
Which the blueprints designate as interactivity.
Right.
And the transition from augmentation to interactivity, it really represents a profound shift in the interaction model. The sources provide a stark comparison between traditional analytics and conversational analytics to illustrate why level 2 is so necessary.
Let's break down that traditional analytics bottleneck because I think a lot of listeners will really feel the pain of
Well,
this.
they definitely will.
In the traditional enterprise BI model, if a business user, say a sales director or a warehouse manager, wants to ask a complex ad hoc question about their SAP data, they face this massive technical barrier to entry.
It's a huge wall. The data lives in complex relational H&A databases. You have dozens of tables for customers, orders, materials, logs, all linked by these obscure primary and foreign keys.
Right. A business user cannot just ask a question, they have to submit a JIRA ticket to a data engineering team.
And then the wait begins.
The dreaded wait.
Yep. The data engineer has to interpret the business user's request, write the highly specialized SQL query to extract the data across multiple joins, and then pull that data into a Python or R environment for manual data frame manipulation.
Just to clean it, aggregate it, and format it.
Exactly.
And even after all that manual data frame manipulation, you still just have a flat file of numbers. You then have to push that through an entirely distinct visualization workflow,
Right. The data engineer hands the file to a BI analyst.
who then loads it into Tableau or Power BI, builds the charts, and publishes a static dashboard.
And if the original business user looked at that dashboard and says, actually, can I see this filtered by the EMEA region instead of North America?
The entire multi-day cycle starts over. It is an incredibly high-friction environment for strategic decision-making.
Which is exactly the friction that Blueprint 2 eliminates. This level introduces an abstraction layer known as Pandas AI.
Pandas AI. Okay,
This marks the transition to conversational analytics. So instead of navigating that complex SQL and BI dashboard lifecycle, the business user interacts with the data using natural language.
here's where it gets really interesting. The blueprint details a 4-stage text-to-insights engine that powers this interactivity.
And it looks like absolute magic to the end user. But under the hood, it is a highly structured, orchestrated sequence.
Let's walk through the mechanics of this engine. Break down the stages for us.
Sure. So stage one is the capture of human intent. This is the initiation of the workflow. The user provides a natural language prompt directly into the interface.
Okay, the blueprint provides a concrete example of this, right?
It does. The user simply types df.chat. Lists the hotel names sorted by nights reserved.
That's it. No select from, no inner join, no complex grouping logic.
None of that. Just plain English intent.
Wow, how does the architecture handle that in stage 2?
Stage two involves the Pandas AI engine. Pandas AI is this advanced Python library that acts as a cognitive wrapper.
A wrapper.
Yeah, it wraps around the SAP HANA data frame, which contains the actual business data, and it simultaneously establishes a connection with the Amazon Bedrock LLM.
Oh, I see.
The engine takes that human intent from stage one and routes it over to the Claude model on Bedrock.
So Bedrock is essentially acting as a real-time semantic translator here.
Exactly.
It isn't answering the question based on its own training data, right? It is analyzing the user's intent and mapping it against the schema of the SAP data frame.
You nail it. It understands that hotel names corresponds to a specific column, and sorted by nights reserved implies an aggregation and a descending order operation.
That is wild.
And that triggers stage three. Query resolution. The LLM generates the internal Python code, specifically Pandas logic required to fulfill that request.
Okay, so it writes the code.
Yes.
Yeah.
And crucially, the Pandas AI engine automatically executes that generated code against the live SAP HANA Cloud dataset.
Wait, that automatic execution is the paradigm shift here.
It absolutely is.
The AI doesn't just act as, like, a code assistant that spits out a script for the user to copy and paste somewhere else.
No, not at all. It generates the logic, executes the logic within the secure environment, and processes the data frame operations in real time.
Which culminates in stage 4, automated output.
Yep. The system captures the results of the executed code and returns the finalized insight to the user.
And this output, it could be a simple calculated integer or a newly filtered data frame. Or, most impressively, the Pandas AI engine can generate and render matplotlib visualizations autonomously.
Completely autonomous, without the user ever explicitly requesting a chart or writing any visualization code.
The blueprint's stated goal here is frictionless interrogation of enterprise data. And this 4-stage engine delivers exactly that.
It really does.
The user chats, the AI translates the semantic intent into code, executes the operations against the SAT data frame, and draws the visualization in a single fluid interaction.
The bottleneck of the data engineering team is completely bypassed for ad hoc queries.
We have to look at the business impact examples provided in the blueprints because they really demonstrate the power of this democratization of data.
Yeah, let's look at the hotel manager scenario.
Okay, so there is a scenario detailing a hotel manager utilizing this level 2 architecture. The manager inputs a remarkably vague prompt, provide full analysis of this data for a hotel manager.
That is super vague.
Right. They don't specify which columns to aggregate or what type of chart to build. They just ask for an analysis tailored to their persona.
And the architecture's response is incredibly sophisticated. It instantly computes the macro metrics.
Like the total number of reservations is 7, and the average nights per reservation is 6.57.
But it goes beyond just text, right?
Way beyond.
Yeah.
It dynamically generates a clean, formatted bar chart plotting total nights against the specific hotel property.
That's amazing.
The blueprint shows the visual output. Indian Horse dominates with 15 nights. Airport and Regency are clustered around 13 nights, while Long Beach and Ocean Star trail significantly with 2 nights each.
So the manager goes from a vague natural language prompt to a fully realized visual strategic insight in seconds.
Seconds. There's another example in the sources that highlights the capability to handle complex, multivariable financial questions, too.
Oh yeah, the revenue trend one.
Right. A user asks, how are domestic revenues trending against inventory costs this quarter?
And in a traditional BI setup, that requires joining revenue tables with inventory valuation logs. It's a heavy lift.
But here, the Pandas AI engine handles the underlying complexity invisibly. It interprets the request for a trend analysis, executes the necessary aggregations, and returns a textual summary confirming that domestic revenue is on an upward trajectory while inventory costs remain stable.
And it backs up that text with side-by-side bar charts, visualizing the Q3 revenues versus costs.
It is literally like having a senior data scientist and a BI visualization expert sitting at your desk, executing your thoughts in real time.
The empowerment of the business user at level 2 is undeniable. It's fantastic.
However, there's always a however.
Always. If we connect this to the bigger picture of enterprise architecture, we have to acknowledge a severe structural limitation in this setup.
You know, I was looking at this and thinking, if I can just chat with my data, get instant insights, and have charts generated automatically, haven't we reached the finish line?
It feels like it.
This feels like the ultimate goal of enterprise AI. Why does level 3 even exist?
Because of where this interaction is taking place. The blueprints refer to this as the notebook limitation.
The notebook limitation.
Yeah. Everything we just analyzed in level 2, the Pandas AI wrapper, the real-time execution, the matplotlib charts, it is entirely localized within a SageMaker notebook environment.
Which is an interactive development environment designed primarily for data scientists.
Exactly. It is a sandbox.
Yeah.
A very, very powerful sandbox, but still a sandbox.
It is inherently isolated.
Very isolated. A SageMaker notebook requires a specific user session. It runs on dedicated persistent compute instances that incur continuous costs, and it's not easily accessible outside of the AWS console. Meaning, you cannot take that incredible conversational analytics capability and serve it to the rest of the business.
Ah, I see the problem. So if a data scientist builds this brilliant Pandas AI chat interface in their notebook, the global sales team can't access it from their CRM dashboard.
Right.
A supply chain vendor can't query inventory levels through an external portal. If an automated inventory management system needs to ask the AI a question to trigger a reorder, it has no programmatic way to reach inside the SageMaker notebook to get the answer.
Exactly. The intelligence is trapped in the lab.
Wow.
For this technology to become a true enterprise microservice, it has to break out of the notebook. It must become scalable, stateless, highly secure, and universally consumable by any authorized application in the corporate ecosystem.
This inherent friction, having powerful AI but no way to deploy it at scale, forces the final evolution on the maturity continuum. We arrive at level 3.
And productization.
Productization. The blueprints declare this phase the serverless imperative.
Moving to level 3 requires a fundamental re-architecture. You are basically migrating the cognitive logic out of the localized notebook and deploying it into a distributed, event-driven infrastructure.
And according to Blueprint 3, this means transitioning to AWS Lambda for serverless compute, utilizing API Gateway for external routing, and upgrading the orchestration framework to something much more robust, like LangChain.
Yes. Let's do a deep dive into Blueprint 3. The serverless GenAI pipeline.
Let's do it.
The sources lay out a comprehensive 5-step journey that tracks a single user request from an external application all the way through the AI logic into the SAP database and back again.
This is the absolute culmination of the code to value roadmap.
It really is. So step one is the trigger. We're no longer dealing with the user typing code into a cell. The entry point is now Amazon API Gateway, receiving a RESTful API post request.
Okay, so this request contains the natural language prompt, but the origin could be anything, right?
Anything at all. It could be a button press on a mobile app, a voice command from a smart factory device, or, an automated webhook from another enterprise software system.
The API gateway acts as the secure front door. It handles the authentication, ensures the request is formatted correctly, and then passes the payload to step 2, compute and dependencies.
Which is where AWS Lambda takes over.
Right. And the shift to Lambda is critical for enterprise scale. Lambda is serverless, event-driven compute.
Exactly. The company isn't paying for a massive server to just sit idle waiting for a question.
Lambda only spins up the exact milliseconds a request is being processed.
And that event-driven scaling is essential when deploying AI to thousands of concurrent users. When the Lambda function is invoked, it rapidly unpacks its deployment layers.
In this architecture, those layers contain the LangChain framework and the necessary database drivers. The function initializes the environment and executes the handler logic.
Which brings us to step 3, orchestration. And the blueprint specifies the use of a LangChain SQL agent.
An agent. So we've moved past simple prompt engineering or data frame wrappers. We are now utilizing autonomous agentic workflows.
Yes, we are.
How does a LangChain SQL agent differ from what we saw in level 1 or 2?
Well, an agent possesses agency. It can reason about its own execution path.
Okay.
The LangChain SQL agent receives the natural language prompt from the API and formulates an execution plan using a framework often referred to as React reasoning and acting.
So it doesn't just blindly generate code?
Nope. It analyzes the schema of the SAP HNA cloud database, determines which tables hold the required data, and formulates a plan to retrieve it.
It's thinking a few steps ahead.
Exactly. And then it executes that plan in step 4, LLM and data integration.
How does that step work?
This step is a highly iterative loop. The LangChain agent queries the Amazon Bedrock Claude model, asking it to translate the human intent into valid, highly specific SQL syntax.
Okay, and once Claude returns the SQL string?
The agent takes that string and executes it directly against the SAP HNA cloud database.
But wait, what happens if the generated SQL is wrong? Like, what if Claude hallucinates a column name that doesn't actually exist in the SAP database? In the older levels, that would just throw a hard error and fail.
It would. But this is the brilliance of the agentic approach in level 3. If the SAP database returns the syntax error, the LangChain agent captures that error, observes the failure, passes the error message back to the Claude model, and essentially says, hey, that SQL failed because column X doesn't exist. Rewrite the query using the correct schema.
Oh, wow. It iteratively self-corrects until it successfully extracts the data.
It's incredible. It debugs its own code on the fly.
That is an incredibly resilient pipeline. So we have the API triggering Lambda, Lambda initializing the LangChain agent, the agent utilizing Claude to dynamically write and debug SQL, and successfully executing that SQL against the SAP data foundation.
All of this orchestration is happening invisibly in milliseconds.
Which leads directly to step 5, delivery.
Right. Once the SAP database returns the raw requested data, perhaps it's an array of inventory counts or a calculated revenue metric, the agent might use the Claude model one final time.
To do what?
To synthesize that raw data into a conversational, human-readable response. That finalized payload is then returned up the stack through the Lambda function, out through the API gateway, and delivered back to the external consuming application.
A good analogy to solidify this massive architectural shift. Imagine level 2, the SageMaker notebook, is like having a brilliant personal chef in your own private kitchen.
Oh, like this.
You can walk in, ask for whatever complex dish you want, and they prepare it perfectly. It is a fantastic, highly customized experience for you. But they can only cook for one person at a time, and nobody outside your house can taste the food.
Right.
Level 3, the serverless API pipeline, is like taking that chef's knowledge, systematizing it, and building a highly efficient, fully automated commercial restaurant kitchen.
That scales infinitely.
Yes. It can serve thousands of customers simultaneously, on demand, 247 without breaking a sweat. And the customers, the end users, never have to look inside the kitchen or understand how the ovens work. They just place an order and get their food instantly.
That perfectly encapsulates the concept of productization. The AI capability transitions from being an isolated tool into an invisible, infinitely scalable utility that powers the entire enterprise ecosystem.
So we have thoroughly explored all three levels of the maturity continuum. We've got the batch processing of augmentation, the constrained exploration of interactivity, and the scalable deployment of productization.
It's quite a journey.
It is, but if you are an enterprise architect, a CTO, or a data leader listening to this, how do you actually synthesize this blueprint? Like, how do you map these concepts to your immediate business needs?
Well, the sources anticipate this exact challenge, and they provide a highly structured tool. They call it the diagnostic matrix.
A diagnostic matrix sounds like a cheat sheet.
It basically is an architectural cheat sheet. It maps the primary AWS service, the SAP data source, the specific AI framework, the interaction model, and the ideal business use case for each of the three scenarios we've discussed.
So it's designed to prevent organizations from over-engineering or under-engineering their AI solutions.
Exactly. You don't need a Ferrari to go to the grocery store, and you can't win a race in a golf cart.
Let's break down this matrix to help operationalize everything we've covered. Scenario 1, the augmentation phase.
Right. In scenario 1, the matrix defines the interaction model strictly as batch processing.
Okay.
The AI framework is the Bodo 3 Bedrock client, and it operates primarily on static documents, like those PDFs we discussed earlier.
The dreaded RFSSLD000.pdf.
Exactly. The ideal business use case here is the rapid summarization of periodic financial reports, audit logs, or compliance documents.
So you choose this architecture when your primary goal is removing the manual human bottleneck of reading dense text, and you don't require real-time interactivity.
Yep. It is the fastest path to ROI for document-heavy workflows. Simple, contained, highly deterministic.
Okay, scenario 2 is interactivity.
The matrix shifts the interaction model here to conversational chat.
Right.
The AI framework upgrades to Pandas AI, operating directly on live HANA data frames, but contained within SageMaker notebooks.
And the ideal business use case.
Ad hoc, visual data exploration by internal business users. You deploy this scenario when you need to empower your management team to interrogate their data and generate charts instantly.
Bypassing the traditional BI engineering queue.
Exactly. But you use this when you don't need to expose that capability to external applications. It stays internal.
And finally, scenario 3, productization, the ultimate destination.
The big leagues. The interaction model here becomes a programmatic API.
Okay.
The AWS infrastructure shifts entirely to serverless event-driven compute with Lambda and API Gateway. The framework utilizes the LangChain SQL agent to query the HANA Cloud SQL database autonomously.
So when do you choose scenario 3?
You choose scenario 3 when your business mandate is embedding generative AI capabilities deeply into external enterprise applications, customer-facing mobile clients, or automated high-volume workflows at global scale.
So what does this all actually mean for the future of enterprise technology?
It's a big question.
It is. When you step back and look at the sheer scale of this blueprint, from extracting static text using zero temperature prompts to building a resilient, self-correcting serverless API, a few things become undeniably clear.
Yeah, the main takeaway is that true enterprise GenAI is not a widget you bolt onto your website.
Exactly. It is a deliberate, structurally complex architectural integration. It requires the deep, immutable data foundation of SAP, the elastic, event-driven infrastructure of AWS, and the advanced semantic reasoning of Amazon Bedrock working in seamless high-speed concert.
The overarching lesson from these blueprints is that data without reasoning is merely cold storage.
Right.
And reasoning without grounded data is just an expensive hallucination.
That is perfectly said.
It is only by architecting them together, securely and at scale, that an organization achieves actual enterprise intelligence.
We have covered a massive amount of ground in this deep dive. We started with the painful, relatable reality of manually parsing a high-density SAP financial report and tracked the architectural evolution all the way to a serverless, universally consumable API capable of interrogating an entire enterprise data foundation in natural language.
It's quite an evolution.
We've seen how viewing AI merely as a conversational chatbot vastly underestimates its utility. In the enterprise domain, generative AI is a foundational architectural component. It is the new cognitive routing layer of the corporate ecosystem.
And, as we conclude this analysis, the trajectory of these architectural blueprints raises a highly provocative question.
Oh, what's that?
Well, throughout this deep dive, we have focused extensively on how AI acts as the ultimate translator, the intermediary layer between human intent and complex databases.
Right. A human asks a question, the AI writes the query, retrieves the data, and delivers the answer.
Exactly. But As the serverless pipelines in Level 3 become increasingly resilient, highly secure, and capable of executing automated enterprise workflows
Yeah.
without requiring a manual human trigger.
Oh, I see where you're going with this.
How long until the AI stops merely answering our questions about the SAP data
Yeah.
and starts independently optimizing the business based on the insights it discovers on its own?
That is a staggering thought to leave you with. Imagine a level 3 architecture that doesn't just wait for you to ask why inventory is low, but actively monitors the SAP telemetry, identifies a probabilistic supply chain failure, dynamically analyzes the cost variables, and automatically executes a workflow to renegotiate a supplier contract before a human is even aware there was a problem.
The architecture to support that future is already on the page.
It really is. Thank you for joining us on this deep dive. We hope this roadmap helps you navigate the incredibly complex, rapidly evolving landscape of enterprise AI. Keep exploring, keep questioning the architecture, and we will talk to you next time.